she is. Everybody's here. Awesome sauce. Means that's ready to go. That's ready to go. And we're actually ready to begin on time today. Amazing. All right, then. Do this. Good morning, everyone. How are you all doing? Second week. Problem solving is away. Today is going to be a real short video and potentially a short class, depending on what level of assignment you are aiming for. We're just going to work on the problems for today. The problem set from yesterday, a whole class dedicated to just giving you time to work through them. I'll be here to assist you, answer any questions, maybe give you some hints or some possible guidance to prod you along as you start to get used to this. So first up, let me open up the problem set. I've gone ahead and set them in a page here. And I'll just go through each one, or at least the level 1 problems, the minimum that you need to get done, and give you a couple hints. All right? So if you don't want well, spoilers, there's one already on the screen. Shoot, I didn't think of that. If you don't want them, tune out, don't listen, don't watch. Just work through it on your own. But they're minor hints just to get you started, okay? A direction of how to begin. So the first problem we have to address is this one. How many equilateral triangles of all sizes are there in the 3 by 3 by 3 equilateral triangle shown next? And because this is the beginning of the geometry book, it is not assuming that you already know equilateral triangle. That'll be a fresh vocabulary term later when they get to the triangle chapter, right? So my hint for you is much like we did with the squares, the 3 by 3 squares, I would say start by sketching out the 3 possible sizes. Spoilers, there's 3 sizes, right? A 1, a 2, and a 3, right? All the sizes of triangles so that you can better keep track of them as you count. Okay? And refer back to the squares one that we did as an example yesterday. It'd be very similar, right? This is just the same thing, but now it's triangles. We kind of talked about that as when we were thinking about how can I take this square problem, what could be changed to make it a different problem, how would that affect my strategy? Right? We mentioned, oh, it could be a different shape, triangles or pentagons or something. Right? Here is the version with triangles. So how does the strategy, the method for solution, right, for this problem compare to the other one? If they're very similar, use the same technique. No need to reinvent the wheel unless absolutely necessary. All right, next up, number 3. It introduces a new type of shape, the tetromino. Perhaps you've played with dominoes before. Dominoes, right? Dominoes have 2 squares attached. A tetromino, tetra comes from Greek for 4, so it's 4 squares all connected to each other. Imagine playing a game of dominoes with these funky shapes. Or some other kind of, maybe you can make a video game out of this, trying to piece all of these together. I don't know. Sounds a little far-fetched. But in case that doesn't exist, I would recommend starting with 1 block. Draw a single square and expand from there. Okay, I could go this side, and we could add another one this way, or, right? And just kind of work your way around. How can I add squares to this to create a new shape? Until you've gone every possible method, right? And then I mentioned something about, right, you want to make sure that if they flip over, you don't get the same shape. This is where having a piece of paper really makes this easy, because you can look at your page and you can literally like spin it around and say, oh wait, that's the same thing but upside down. Okay, it's not a new one. Right, so there you go, double hint on problem 2. And the third level 1 problem comes from question number 10. Determine if exactly 6 squares of the 3 by 3 grid shown can be shaded so that no 3 shaded squares line up horizontally, vertically, or diagonally, right? So they're talking about, can I go in here and start coloring in, shade 1 square, and then we'll shade the next square, right? And then we shade the third square. No, wait, that's a line. Oh, shoot. Okay, so we can't do that square. Find a different square, right? Can you fill in 6 squares that way? If that sounds like a lot of things to keep track of, well, there's 9 squares total. You're filling in 6, so what if instead you considered only the 3 empty squares? Okay? And if you want an example of a similar problem, go back to the draw a picture section. From the text, there was the milk crate problem. Let me see if I can pull it up here. Nope, that's the question here. Guess and test. Draw a picture. Had the example, and then there was the additional problems. Okay, you had this guy right here. Additional problem number 2 for draw a picture. Mentioned a milk crate with spaces for 24 bottles, but they only filled 18. And they similarly wanted so that each row and column had an even number, right? So similar type of problem and similar type of solution. So maybe take a look at that problem and see what information you can glean from it that would help you on the other one. Okay? So there you go. There's some information to start you off if you haven't got that far already. Anyone have any immediate questions for today that I can answer? No? Okay, then please use the remainder of the class time to work on these problems. If you finished the level 1 problems, go on to the level 2s. Try those. Those are some really good ones in there. Some of my favorites ended up in the level 2 slot. Classic math scenarios. You got to at least read them, okay? So you understand where I'm nerding out from, okay? But otherwise, I will leave you to